So what is a magnetic locator? Well, very simply, it's an instrument which responds to the changes in the Earth's magnetic field. These changes are caused by the presence of ferrous metals. Ferrous metals are those containing iron. So they will sense and react to objects with high ferrous content. It's a passive instrument, so we don't transmit any energy at all. And we can detect objects up to 6 meters deep. Probably fairly obviously, the larger the object, the more metal, the deeper we can locate. So what will they find? So any iron and steel object. So survey markers, for those who are not familiar with this, this is a major application in the US, and these will be used as property markers. So the iron rod is put in the ground at the corners of a property, and that defines the edges of property. So the edges of your land. So it's a line defined between property markers. Valve and curb boxes. So any of our valves or our curb boxes that are buried in the ground, we can locate them. Manhole covers, which quite often get buried. Mag nails. So this is one for surveyors. We normally recommend our GA52 or the Maggie for these, the most sensitive locators. So surveyors, any surveyors out there will know that what happens all too often is that the nail gets buried by somebody working on site. You're going back to try to find your occupied point, and it's just not there. Steel pipe joints, very, very interesting application. Because of the way magnetic locators work, we can actually see a change in the magnetic field at the joint. So we can actually find along pipes where the joints are. And this is where you're normally going to get leaks. Well castings, well casings, these are normally quite big, so we'll find them to quite considerable depths. Septic tank handles. Septic tanks will normally be concrete or plastic or some other material, but the tank handles tend to be ferrous, so we can find them. And underground storage tanks. So again, the bigger the tank, deeper the potentially we can find them. Steel drums. So buried steel drums in the ground. And unexploded ordnance. This is a major application, either with charities, for NGOs, for the military, and even in civil engineering, where you may have what they call high-risk areas. We have them in the UK, certain areas in Europe, where there is a history of abandoned ordnance, basically bombs that haven't gone off, probably from previous wars. So magnetometers are used when digging in this area. So what will they not detect? Aluminium, brass, copper. And we refer to these as the ABCs. So drink cans and tops, coins, and most underground cables. Remember, it's a passive instrument and it will not disrupt any utilities, communications, or electric lines while in use. So we don't have to consider whether or not we can use this equipment in a certain area. So let's look at the science behind magnetic locators. A short video here, which I'll play, and this will tell you a little bit about the science behind the locators.
The basic principles of magnetic locating. Understanding the principles of magnetic locating will prepare you to effectively use Schonstedt locators. The Earth behaves like a large magnet, and its magnetic field is typically represented with lines, much like it is for a common magnet. So, at every point on and below the surface of the Earth, there is a level of magnetic field present. Objects made of certain materials, such as iron and steel, are affected by this field in such a way that they develop their own magnetic field, very similar to that of a magnet. By contrast, buried objects made of non-magnetic metals, such as aluminum, copper, and gold, are not affected by the Earth's magnetic field, and therefore can't be located by magnetic locators. Schonstedt magnetic locators operate on the principle of detecting the difference in the magnetic field present at two sensors spaced a fixed distance apart. In the absence of a buried object, the field at both sensors is the same. The presence of an object made of iron or steel results in a difference between the magnetic field at the top and the bottom sensors. That difference is called a gradient. Schonstedt locators indicate the detection of a gradient to the user by changing the pitch of an audio tone and, depending on the model, with a bar graph on a visual display. The size of the buried object has an impact on the size of the magnetic field difference, or gradient. Likewise, the orientation of the buried object also has an effect on the size of the gradient detected. The same object oriented vertically will generally produce a larger difference. Some Schonstedt locators also indicate polarity, which can be useful in determining if the target is oriented vertically or horizontally. This is accomplished by observing the polarity change at each end. The fixed spacing between the sensors determines the overall length of the locator and has an impact on the field difference detected, or the sensitivity of the locator. The further apart the sensors are, the more sensitive the locator is. Schonstedt offers magnetic locator models with various sensor spacing, plus audio and visual indicators. The basic technique to locate a buried object with a magnetic locator involves approaching the object while listening to the pitch of the tone and, if applicable, watching the bar graph on the display. Once near the object, small X-pattern movements help pinpoint the exact location of the target. Volume and sensitivity can be adjusted on all Schonstedt locators to accommodate various depths and sizes of targets, as well as background noise conditions.
So I hope you found that interesting. So let's talk about applications and best practice for magnetic locators. So as we've seen in the video, deciphering the size and the shape of an object, X marks a spot. When you've detected the object by sweeping, locate more precisely by slowing down, hold the locator vertically, and start to move in small X patterns. So we will pinpoint the ends of large objects, so we can find the edges of, say, a manhole, but small objects, we will just find a single response. So we can find shape, size, and position. There's a couple of ways of adjusting the sensitivity. One of them, raise the locator several centimeters, because raising the locator several centimeters also helps us with what we call resolution. So it'll give us an idea of the size of the object. So we can see there, raise the locator or adjust the gain control. Adjusting the gain control, fairly obvious, reduces sensitivity or increases sensitivity. So when we talk about raising locator, we talk about resolution. We can see here the response above the ground, high above the ground and low to the ground. So the smaller the object, the quicker the response will reduce as we raise it. So this will help us when we find the object, we can adjust the sensitivity down get it to an appropriate level, then just start raising it, and that'll give us an idea. Is this a big object? Is it a small object? Locating a metal pipe. So long ferrous metal objects such as pipes, they have magnetic fields that stretch beyond the ends. So this is not just jointed pipes, this also works with welded pipes. So it's quite important to be able to find these welds or joints sometimes, because typically if you're going to have a leak, it's going to be around the weak spot, which shouldn't be the weld, but can be the weld, or around these joints. So to start with, set the gain to maximum. Hold the locator between 300 and 450 millimeters above the ground. So a foot to 18 inches. And hold the locator steadily and walk along the suspected pipe's path and make temporary markings at the readings. Now you can use this in conjunction with electromagnetic locator. So if you've already marked out the path of your pipe using your EM locator, this is what you can do to find the joints. Then reduce the gain for a second path and hold the locator close at the ground and pinpoint the peak response near the previously marked spots. So these marks at the peak response will reveal where the joints are. So if you have one of our GA92s or our Maggie or our GA72, these have an LCD display. So we'll just have a quick look around the LCD display. We have the sensitivity level indicator. So 4 sensitivity levels on this particular locator: low, medium, high, and extra high. And we have our sensitivity controlled buttons there on the membrane switch. And then the battery level indicator between full and 25% left. In the center, the LCD, we have the magnetic field polarity, plus or minus. The signal strength in differential milligauss. And then we have a negative polarity expanding bar graph and a positive polarity expanding bar graph. So the bar graph will expand positive or negative, and the digital readout shows the peak. And the tone of the instrument will also rise at the pole. So if you're using a GA52 or spot, then you will just be listening for the tone. So we can see there, we've got a vertical rod. So we'll just have a single response, and then we have a rod laid on its end. And with this, we will have a response at either end. Magnetized markers. Now, this could be a piece of iron pipe. This could be a piece of reinforcing bar. And this is what's typically used for property markers. So with this, as we would expect, we'll get a strong response directly over the object. But we also have other responses. So it's key that you understand how to distinguish between the responses so we can pinpoint exactly where our target is. So we don't start thinking that there are other objects either side. So the weak responses, these are due to the sensitivity of the equipment. So we get because of the shape of the field, we actually get a null and then a little response either side of it. So at points B and C, the magnetic field intersects this axis perpendicularly. So this reduces the differential between the two sensors, and this is known as the null. So we can see there we have the peak, we have a null, and then at points A and D, we have a small signal either side of the peak with a null in between. So what you've got to appreciate is you're actually going to get this null all the way around and this peak all the way around the main signal. So don't confuse it for another object. So just use your X pattern over the object and look for your peak. And if it is a marker you're looking for, a property marker, then this sort of signal will become familiar to you. If we're burying magnetized markers, best practice before we do so is to check either end, because we're going to have a north pole and a south pole. So check which end has the strongest response and bury it with the strongest response facing upwards. And this is going to help anybody else who's trying to find that magnetic marker later on. Buried steel drums. Now, buried steel drums, these could just be ditched in the ground, or they could be used for burying, for nefarious purposes, for burying stolen goods, burying anything. So it's important that we be able to locate or identify what sort of response we're going to get from a steel drum. So if these are buried between 1.5 and 2.5 meters deep, what we're probably going to get if they're stood on end is just a single response. Because as it gets deeper, the dual response that we get, so for a shallow vertically buried drum, at a shallow depth, we would get a response either side of the top of the drum. But as it gets deeper, we get a single response. As we turn it on its side, depends how it's buried, we may get a response at either end of the drum. So we get a positive or negative either side. But again, as it gets deeper and deeper, this will fade away into a single response. Septic tank handles, as we mentioned earlier on, if we're looking for a septic tank, the best thing to try and find is the handles. The septic tank itself could be made of concrete, smaller ones may be made of plastic, but the handles tend to be made of ferrous metal. So we'd be looking for a response from the first handle. We'd normally be looking for a couple of handles. So to find the orientation of the tank, look for where we get the responses, and that will indicate the orientation of the tank. UXOs, again, you can probably see a pattern emerging here. Depends whether something's vertical or horizontally buried. So we could either get a single positive and negative response or get two. Depends in which direction the ordnance is buried. The bigger the ordnance, the better response we're going to get, the deeper we'll locate things. If we are locating UXOs or any metal, we're going to get water's not going to affect it. So being buried in water doesn't affect our ability to locate. We'll still get our signal. And also, as we mentioned earlier, if we are looking for ordnance and there's a potential for being shrapnel around, raise the locator. And if the signal disappears quickly, well, that means it's a smaller piece of ferrous material. So if you're looking for quite large bits of ordnance, it could be a piece of shrapnel or another piece of ferrous metal kicking around just underneath the ground. And that quick change in the response will indicate a shallow object. So what sort of depths are we going to be able to find weapons and ordnance? So a handgun, we typically be able to locate down to about 250 mil. Probably the same for an 81mm mortar shell. So if we're getting up to 175mm artillery shell, we'll probably get that down to about 1 meter. And quite a small, a Mark 81 low drag bomb, 2 meters plus. And as with everything, the size will influence how deep we can locate them. One of the challenges with using a magnetic locator is working next to metal fences. Now, there is a solution to this. And what you have to do is hold the locator horizontally next to the fence along the ground. So reduce the gain setting and hold it horizontally. What you're doing here is you're keeping the upper sensor away from the fence. And you want to be between 15 to 25 mil away from the fence. And what you will get a null. So you get a peak either side of your object, and you will get a null right where your object sits. So here you'll be able to search an area several feet wide and then come in and out to actually find where your object is. But here, essentially what you're doing is using a single sensor. So here, when you're directly over the ferrous object, there'll be a sudden drop in the signal strength. So just work along. If you pick up a signal, work in and out, where the signal drops, that's where you're going to get your response. Another application, barbed wire. Now, barbed wire, if it's in a tree, this can be hazardous for chainsaw operators. So if you're working in an area where it's quite clear that, or maybe clear that, you know, this tree may have been used as part of a fence, you may have barbed wire in there, will have grown into the tree, and this can cause a chainsaw to bounce, damage the chainsaw or damage the operator. And barbed wire in the ground, this can be quite hazardous to rotating machinery. Now, we can either get the barbed wire wrapped around the rotating machinery, or you can throw it up, and all, you know, it can be hazardous thrown up to and make contact with people. So how deep typically can we detect objects? So survey marker, 18-inch rebar, up to about 2.75 mil, 2.75 meters. A mag nail down to about 300 mil. Iron pipe up to about 3 meters. Obviously, it just depends on the size of the pipe. Iron valve and curb boxes, again, down to about 3 meters. Well castings, up to about 5.5 meters. Ordnance, again, down to about 3.6 meters. Steel drums, about the same. A lost manhole cover, again about 3.6 meters. And septic tank handles, about 3.6 meters. This is all dependent on the size of the object you're trying to find. How much ferrous metals there will determine how successful we're going to be at locating them. So telecoms, electrical power, and Cat TV cables. Now, this may be surprising because I've already said that you won't find cables. The kind of cables we're going to find are ones that have got metal sheaths. So armored cables. So if there's a big cable with a lot of armor in there, we'll be able to find them. Tracer wires, magnetic markers, and metallic pipes, again down to about 3.6 meters. And the bigger it is, the more likely we are to find it. Something we've got to consider when we're using magnetic locators is congested areas. So what I mean by congested areas is areas which have other bits of metal around in them. So understand your surroundings. So, you know, if you've got big lumps of ferrous metal like cars, you're not going to have much joy in finding things in the ground working next to a parked car. Appreciate that you may have rebar in the ground around the foundations of a building. Working next to something like a palisade fence or a metal building, yes, there's ways of doing it, which we've outlined. Working next to Armco barriers. And another key point is, if you're going to be using magnetic locators, make sure you invest in some composite safety boots, not steel capped safety boots. Otherwise, you'll just follow your feet around all day. So the product line. So the most sensitive in our range, well, this and our GA52, is the Maggie. So the Maggie's got the highest sensitivity in the range. It was introduced for the gas and water industry with the visual display, audio and visual display, as a pistol grip, ergonomic handle. As you can see there in the handle, there's a little thumb screw there, and this is where we get access to the 9-volt battery. And it has an IP rating of 54. When you get buy a Maggie, it comes in a soft case. Now the GA52CX, the old man of the range, and this has been around since the 1970s, not in its current form, 1994 in its current form, and it's still hugely popular with surveyors in the States. So the GA52 is rugged. It's actually got an aluminium structure. The sensors are held inside an aluminium pole. High sensitivity, 5 levels of sensitivity, audio only. So it's got an audio output and it has a headphone jack in case you're working in very noisy environments. Comes in a hard plastic case. And part of the success of the GA52, like all of our locators, is the high performance components. We have a very tight tolerance on our production process, and this has helped this to be such a successful range of locators. And again, IP54 rated, and it's completely waterproof up to the switches, so you can actually drop this into water, but not the control. And it's still the most popular choice among surveyors in the States. Next in the range is our GA72 CD. Now the GA72 is very versatile. It has its audio and visual display. It displays signal strength and polarity, the same as the Maggie. Battery and sensitivity indicators. Choice of audio output mode, so we can actually have it. The speaker there is in the top of the handle, or again, we can plug headphones into it. We've got a headphone jack. And again, this comes in a hard case and is IP54 rated. Now, the other thing about the GA52 CD is the most popular locator for use in the UXO field. So one thing we're very proud of at Schonstedt, when SPX took over Schonstedt, one thing that we're very keen to carry on with was the humanitarian demining initiative. So we work in conjunction with UNMAS, which is the United Nations Mine Action Service. And we have deployed these all over the world. So we got some photos there from United Nations Mine Action Service. And the center one at the top was actually the Norwegian People's Aids in Palau, which was one of the Pacific Islands involved in the Japanese invasion during the Second World War. So there was a lot of fighting on these islands. So you can see there's a lot of ordnance from the Second World War there on Palau. So the United Nations Mine Action Service deploys these things all over the world. And as part of that, we partner directly with them and the US State Department to deploy magnetic locators for landmines, cluster bombs, what we call explosive remnants of war, and other unexploded ordnance. So we have a scheme which we've been running since 2007, and anybody that purchases a GA72CD for donation, we match that donation on a one-to-one basis. So if anybody wishes to give or donate a magnetic locator, when they donate one, we will donate one as well. And they will get a letter from UMass and from the US State Department thanking them and telling them where it's being deployed in the world. So we can see here the 625 locators that have been deployed as part of the United Nations Man Action Service. And we can see the places in the world where we've actually sent there to help with the humanitarian clearance of ordnance. So it's something SPX are extremely proud of, took on from Schonstedt for, our efforts in helping the humanitarian clearance of the old ordnance from wars. The next in the line is the GA92 XTD, which looks very similar to the Maggie. And it is fairly similar to the Maggie in its controls and its looks, except it's not quite as sensitive as the Maggie because it's got a shorter space between the sensors because it expands. This will sit quite small in a small case, and then you actually pull the sensor out of the housing. So it's compact and portable and retracts for easy storage and convenient carrying. Again, audio and visual display, comes in a hard case and IP54 rated. And as we said, it's less sensitive than the Maggie and the Spot and the GA52 because of the distance between the sensors. Then the Spot. Now the Spot was one we introduced as this is the most affordable Schonstedt. It's rugged plastic. It was designed to have a more of an ergonomic design than the GA52 because you actually held it as opposed to holding it below the control box. It's very, very durable. Again, has 5 levels of sensitivity, the same as the GA52. And again, is IP54 rated. And this comes, like the Maggie, comes in a soft case. So there is the Schonstedt magnetic product line. Each of the products got its own place within certain industries or the preference of the user. All of them utilize the same heliflux sensors. And these 2 sensors are placed within the locator. And as we mentioned throughout the presentation, the distance between the 2 sensors will determine how sensitive the locator is. So we can see there the magnetic locator comparison chart. So choose the right locator for you. Any guidance you can get from radio detection or from your local agent. So if you're looking to add magnetic locators to your detection ranges or your toolkits, then just get in touch with us and we can recommend a locator that will fit whatever use you've got for it.